Then coming to the second most important for a human part, or it is important for different mammalian systems or vertebrate systems, that is auditory cues. Now, non-vertebrate or invertebrate systems usually don't have that sort of auditory signal transmission, but it is prominent in insects and arthropods though. But apart from that, it is pretty much mostly seen in vertebrates. So the auditory signals are modality for hearing sounds. So when we talk about sound, we understand that sound is a form of vibrational energy which transferred across air or water or any medium that is concerned with. In air, it is usually perceived as a sort of change with respect to vibration as well as air pressure. Okay, and it depends on which medium it is traveling. Apart from that, it has multiple properties, and the physical property defines the wave nature of its origin. Okay, so it has frequency, it has amplitude, it has wavelength, how the waves are perceived as. So when we talk about physical properties of sound, we include frequency and we see differences with respect to the frequencies. So the frequency is number of wave cycles per second. Okay, so how much of wave cycles happens per second. So in here system, you can see these are pretty long waves, and you can clearly see that the frequency is pretty low. I mean, it is 0.25 hertz. I mean, for a particular wave to complete from here to here, this is a complete wave. It takes 4 seconds. Yeah. So how much of wave travel per second? 1/4. So it is 0.25 hertz. Yeah. So when we talk about amplitude talks about the distance between the peak of the trough and the crest. So this is the height, entire amplitude. So this is the amplitude. Okay, so distance between the peak of the crest and trough. Okay, the high point and the low point. So this is the how big is the wave. So it is measured with respect to decibels. And then there's a wavelength. Wavelength is the difference between a consecutive crest or a consecutive trough. So it is the difference between, so like this much, what is the difference between this or this much? Yeah, so this is the wavelength. It is usually measured in respect to nanometers. So when we talk that these are the physical properties of wave, and it is common to any waveforms. Now the thing is, which is important to respect of sound, pitch. Pitch is a modality of frequency. So it is different from that of the frequency because the perception of pitch varies with respect to different kind of organisms. So it is a sort of frequency with respect to the availability of sound. Okay, what kind of sound is it coming? Then there is loudness. Loudness is the intensity of sound. How loud is the sound is? So it is a perceptual state. Okay, so something can be loud in the beginning and slowly decreasing down as well. So it is not just the amplitude, but the variation of how loud is it coming. So it depends on the air pressure as well. So it depends on many factors. The pitch and the loudness of a sound depends on many factors. Yeah. So then comes timbre. Timbre is sort of the tonality of a particular system. Now the thing is, a same instrument or a same object can produce sound in multiple pitches or multiple loudness, but it is also possible that there is object A, object B, object C, all are producing sound in the same pitch, same loudness, okay, but appear different. For example, when you see multiple instrument playing a flute, okay, let's say a flute, this is a guitar, and this is a piano. Okay, so all of them can produce a pitch or a sound. All of them can produce sound in the same pitch and loudness. Let's say at a particular note, that is A sharp. So A sharp is a note. Let's say A sharp. All of them are producing sound at 2 decibels. Okay, so the same sound of A sharp will appear different in flute, in guitar, in a piano. So this is called the timbre or the tonality of a particular sound. Okay, so these are the perceptive properties of a sound. So it differs with respect to the perception. And all of these varies with respect to different environmental factors. So the loudness decreases when there are a lot of obstacles. And the pitch also varies with respect to that. In an evergreen tropical forest, the sound will be lower with respect to that of a grassland or open system. The sound will be more louder if it is a hill because there is the echoing and reverb. So there are multiple properties of sound. Like there is reverb. Reverb is a sort of addition of multiple short waves in the large wave. So when you talk in the bathroom, okay, so you see whatever you feel is not echo but reverb. Echo is a sort of different signal where it just reflects back. Reverb is sort of addition of small waves. Okay, so whenever you talk in a closed room, the sound is getting amplified with respect to small waves adding to it. So that is reverb. Yeah. So if there is repetition, there is repeatedly verbal systems. So that is reverb. Whereas echo is just repeating signals of one particular call. Right. So all these factors altogether forms the idea of how different animals communicate through auditory signals. So there might be different type of auditory signals. Vocalization are usually the signals which are produced with the respect of vocal cords or vocal sacs. So it can be vocal cords like right I am doing right now, and there could be vocal sacs like you have seen in frogs, okay, in animals, in baboons. We also sometimes use our mouth with respect to movement of the vocal cords. So the vibration that are produced from vocal cords are interpreted with our mouth. So all these are called vocalization. Then there is stridulations. Stridulations are movement of different body parts or repeatedly striking our body part to produce sound. So this is pretty common in case of insects. Like you've seen chirping of crickets and grasshoppers. So they usually tap back their wings and legs to produce different sounds. So that is called stridulations. Then there is vibrations. Vibrations are non-verbal or non-vocal vibratory signals. So when I thump my body, okay, so different organisms and lizards thump their body, and you have also seen the shaking of rattle in rattlesnakes. So these kind of signals, or movements are called vibratory signals or vibrations, because these are not produced from vocal cord or vocal sacs. And they are not stridulations, because stridulation is pretty prominent and have complexities. They have words, syllables of stridulations. Okay, but vibrations are pretty simple and they are used to modify or show a simple signal. Then there is supersonic sounds, which are used by bats. If it is above 20 kilohertz, then it is used by different echolocations, as well as it is pretty accurate with respect to the signaler, and as well as the receiver, that it is the same body. And then there is infrasonic sound. Infrasonic sounds are produced and used by different organisms like elephants. They are also used for that to communicate within different organisms, and it is usually for longer period of time and travels a longer wave, because infrasonic sound have waves with larger wavelength and they travel in a longer period of time or a longer place. So these are also used by different dogs and different mammalian systems as well as insects.